Okay, so in this short video we are going to be investigating how we convert complex numbers which are in Cartesian form into polar form. Now recall, polar form is in the form of r theta, where r is the modulus and theta is the argument. So let's consider Z1, 2 plus 3j. I think the easiest way to do the conversion is to first of all draw your complex number on the Argand diagram. So what have we got here? We've got 2 plus 3j. 2 represents a real part which lies on the x-axis, so it's 2 across, and then 3j is the imaginary part, and that's 3 up, so it's 3 on the y-axis, so our complex number is at that point there. Now I'm going to draw a line from the origin to the point Z1, and I'm doing that just to help me convert it into polar form. So in our r angle theta, our theta is the angle the complex number makes with the real axis, and that is coming anti-clockwise from the real axis, and r is the length of the line from the origin to the point. So let's have a look at what we got here. We have 2 across, and we go 3 up. So if I want to find my modulus for Z1, I have to use some Pythagoras. It's a right angled triangle. It's 2, 3, and then to get that length there, I'm going to do the square root of 2 squared plus 3 squared. 2 squared plus 3 squared gives me 13. So I can say the modulus of Z1 is the square root of 13. So this length here is root 13. Now, to find my argument, I need to find the angle theta. Now again, this is a right angled triangle. 2, 3, and I want that angle theta. So when dealing with right angled triangles and finding angles, we use our SOHCAHTOA. And let's consider what sides we have. If this is our angle, we have the opposite, which is 3, and the adjacent, which is 2. So opposite and adjacent, we're looking at tan. So I can say that tan of theta is opposite over adjacent, so that is 3 over 2. But I don't want tan of the angle, I actually want the angle itself, so we need to do inverse tan, so tan to the minus 1 of 3 over 2. And if you pop that into your calculator, I reckon you should get an answer approximately 56.31 degrees. And that's our argument. It's the angle our complex number makes with the real axis. So I can say that 2 plus 3j can be rewritten in polar form as root 13, and the angle is 56.31. So that's the first one done. Let's have a look at Z2, minus 3 minus 4j. Again, let's represent that on our Argand diagram. So where does minus 3 minus 4j live? Well, minus 3 is 3 steps along the real axis, but to the left as it's minus. It's minus 3. And then minus 4j means it's minus 4 on the imaginary axis, so that's approximately here. So our complex number Z2 lies at that point there, and I'm going to draw this line in again to help me write in polar form. So I think it's important to write down the theta that we're finding and r. So theta is the angle it makes from the real axis going round anti-clockwise. So for this one, our theta is actually all of that angle there. And r is the length of the line. Let's work out r first, as that's a little bit easier to work out. So let's consider the triangle that makes up Z2. It's 3 across, so it's 3 here, and 4 down, so I'll put that as 3, and as 4. I won't worry about the minus signs for now. And that's our r. So again, using Pythagoras, I can say the modulus of Z2 is going to be the square root of 4 squared plus 3 squared. Now 4 squared is 16, 3 squared is 9, so 16 plus 9 is 25. And square root of 25 is 5. So we have the modulus of Z2. The only thing we need to work out now is the argument, the angle. Now, there's lots of different ways we can approach this, but how I'm going to work it out, I'm going to find this angle phi. Okay? Or if I mark it on the Argand diagram, this angle phi here. If I work this out, I can then get theta by just adding 180 to our answer. So let's see what we get. If we take this triangle, we can see that tan of phi is equal to opposite over adjacent, so 4 over 3. And then to get the angle phi, it is inverse tan, so tan to the minus 1 of 4 over 3. And if we pop that into our calculator, you get approximately 53.13 degrees. But that's just this angle phi here. This is just the angle it makes with the negative x-axis round to our number. So that is 53.13. If I want the angle it makes from here, I need to do 180 plus 53.13. So I can see my theta is 180 plus 53.13, which is 233.13. And that is the argument for this complex number. So in polar form, minus 3 minus 4j can be written as 5 with an argument of 233.13. Thank you for watching.